So we are taking up the second problem. So here it is given dx by 1 plus x square. Okay, so it is basically 1 by 1 plus x square, and the lower limit and upper limit is given, and n value is also given. As I said, the restriction for Weddell's rule is basically that n value should be the multiple of 6. That means we can take 6, 12, 18, anything like that, 6 multiple. Already it is given in the question 6, so it is fine. If it is not given, then you have to take 6 as the interval, or you can take 12 also, but it is desirable to take 6 because you can avoid lengthy calculation, because you have to make the table. So many points you have to consider, right? Intervals. So that's why 6 will be better for Weddell's rule. And so formula is given over here. So I is nothing but the definite integral, okay, which is equal to 3h by 10. It is nothing but the width of the intervals we are going to consider. We'll see the formula. Y0, y1, this formula is there. How to remember this formula? Simple. Y0, y1, y2, y3, so on like that, you keep on writing. Then 1 coefficients will be 1, 5, 1, 6, 1, 5, 1, 6. That's basically 15, 16, 15, 16, like that, so on. Okay. So y0, y1, y2, y3, y4, then 15, 16, 15, 16, you keep on writing coefficients. This is how you can remember the formula, or you can find your own way to remember the formula. Okay. Now we have to find the h value. That is very important. So while comparison, see, actual it will be a, b, y dx, and y is nothing but function of f of x. So in this question you can see f y is nothing but this part, dx we cannot consider, right? So y is nothing but 1 by 1 plus x square, right? 1 by 1 plus x square, and a value is equal to what? 0. B value is equal to 12. This you have to remember. Now we have to find the h value, which is equal to upper limit minus lower limit by the intervals. That means b minus a by n. B we know, which is 12, a is 0, and interval is nothing but given in the question 6. So answer will be 2. So we have to take the width of the each interval as what? 2. Let us form the table. So you can go row wise or column wise. You have to take 2 rows or 2 columns. I have taken 2 columns. Okay, so space is not there, that's why. So here the x value, first you have to write the x value. So remember, you have to start with the lower limit, you have to reach till the upper limit, which is nothing but 12. So in this case, the question was basically 0 to 12, right? 0 to 12, 1 by 1 plus x square into dx, right? This was the question. So you can see the lower limit is nothing but 0 and upper limit is nothing but 12. So you have to go from 0 to 12 by taking the h as the step. Step is very important. That means the width of the each interval is important, h. So from 0 I'll take the next step, add 2. Why I have to add 2? Because h value is 2 in the, we have calculated here. So h value is 2, so plus 2, again plus 2, again plus 2. Keep on adding each this thing numbers, so that you can arrive at the final destination, which is something but the upper limit. Okay, so lower to upper we have to go. Next, corresponding, now x value we have written, and corresponding y values we have to find. Y is nothing but a function of x, which is given in the question 1 by 1 plus x square. In place of corresponding x values you substitute 1 by 1 plus 0 square, then 1 by 1 plus 2 square, 4 square, 6 square. Corresponding values you have to substitute. And remember, the first value which you are getting corresponding to x value is nothing but y0. This is very important, which is the first value you have seen in the question also. These values you have to substitute in the formula, right? So y0, y1, y2, y3, y4, y5, y6 we have got. So last value is y6. So till y6 I have to consider, y7 I cannot consider because it is not there. It is basically 0 here. Okay, 15, 16, 14, 16. Now we have to substitute the values. Okay, so I is equal to definite integral 3 into h value is nothing but 2. We have already calculated. Now keep on substituting the value. So we are getting the value for I as how much? 1.37567 after solving. So actual value, if we compare using the formulas, if we calculate using the calculator, if we calculate directly, the answer you will be getting it as how much? 1.48765. This will be the actual value. Okay, so there will be slight variation from the actual value and the value which you have got from the numerical integration method. Okay, that is also there.